Okay, bona ke batla go le bontsha sengwenyana ka speed. Because it's like some of you are struggling with this topic, radioactivity. So ke boletse kwa ntle gore what is radioactivity? With radioactivity, we are talking about emission of radiation from certain atoms called isotopes. We are talking about emission of radiation from certain atoms called isotopes. Yeah. So ka bokhutswane le ke ra gore with topic ya radioactivity re bua ka gore marang, certain atoms di ntsha marang, right? And for our topic today, ra go discuss marang, mehuta ya marang e leng three. So we are going to discuss three types of radiations that are emitted from these isotopes. So, or maybe before the topic, you guys tell for radio. The failure is radio. Radio, it tells you because of this topic, because of radiation. It tells you because of radiation. Because how is the radio? Whatever you are listening to has been broadcasted and received by your radio. It's simply radiation. Yeah. Dipina mafoko a utlwa mo radio a gasiela ka radiation mo re ke radio waves ke marang a tswang ko radio stationeng a gasa whatever se se gasiwa mo radio dipina le mafoko hela yalo. So that's how radio ile atalwa ka teng because of radiation. So it simply means radiation. So you can never discuss this topic here, radioactivity, without talking about isotopes. You can't discuss topic here, radioactivity, or sabuika isotopes. So okay, what is an isotope? Isotopes are atoms of the same element with same number of protons but different number of neutrons. So isotopes are atoms of the same element with different number of neutrons. Yeah. So the main cause of this radioactivity thing is extra neutrons. So you have an atom here, right? And you already know within an atom we have protons and neutrons residing within the nucleus. Outside you have electrons. So one thing I would like to tell you, that I'll just an illustration why these types of atoms within the isotopes, they already have extra number of neutrons. How does having those extra neutrons make them radioactive? Imagine this way. The nucleus is already full. It's filled up with protons and neutrons. It's filled to capacity. Then you bring extra neutrons. Imagine, say this thing is carbon. Say this thing is carbon. Proton number ya carbon is 6. And mass number then mass number then 12. So a carbon atom has got 6 protons. It has got 6 protons and 6 neutrons. So in a mass of 12. 6 protons and 6 neutrons are already filling up that nucleus to capacity. Now imagine if you bring you are bringing in extra neutrons into this already full nucleus. You are bringing in extra passengers, extra neutrons into the already full capacity. But I go botsa ha o robetse le nosi mo ntlong kana mo bolaong la e ka re ba le 10 mogote o nna jang mo ntlong ha le robetse le 100 kgotsa le ha o robetse le 1 o pause video 2 minutes la boa kae. So if you guessed right o tla itse gore ha le bantsi mo roomong go nna bothito ha le kgotlhagane le 10 mo ntlong go nna bothito mo ntlong compared to how lo 1 ile ha go le mariga yaneng ha go le 1 wa sitwa ha le robetse le bantsi go nna bothito. So take the same analogy, apply it. The protons and the neutrons, right? So now imagine you are bringing in extra citizens inside the nucleus. Go rela gore go nna le kgotlagano mo teng ga nucleus, go nna le kgotlagano. Ha di kgotlagana yalo e nna bo hetle mo bang kgata shutela go he mo bang kgata shutela go di a tlala mo nucleuseng. Ha di tletse jalo, that's how energy is being produced. Kgotlagano ya tsone within the nucleus because you brought in extra neutrons. And by the way, instead of carbon being carbon 6, because you brought in 2 extra neutrons, it will now be the identity is 6. So it is still carbon because it has 6 protons. Now that you brought 2 neutrons, 12, 14. Now carbon 14. It is not the ordinary carbon that you know, yeah, carbon 12. This carbon 14 means for it has extra 2 neutrons. The nucleus is congested, and that congestion it will lead to more energy being released from that nucleus. Rather, nucleus is unstable because so it will lead to energy it will be produced, right? And this is what is going to happen. If energy is emitted from this radioactive, because now that ibutito ya ntamarang, so higher butito ntamarang butito, if it releases energy, if energy is being released from this, we call it gamma radiation. Energy that is being released, if it is just pure energy, we call it gamma radiation. And remember, this is the same gamma on the smallest wavelength. Is an electromagnetic spectrum. It is the same gamma or travel at the speed of light. Gamma it is very highly penetrative. Gamma charge. Gamma is massless. And it is not even deflected by a magnetic field. So Lantla, we produce this radiation, energy being emitted from the nucleus. Level 2, because of chuga no how will you tofa? Because we brought in these 2 guys and then because they do khotagan. Electron with them fa. Koko nteka, eka babalwa, electron eka babalwa ke bolwa ra ga go bolwa man. Na ke a sia yana. I can't stand this heat. I'm running away. So if an electron gets emitted from this shell, electron, we call it beta radiation. High electron is right. So the electron is if electron is better that kind of radiation is beta radiation. So you can already know what beta radiation is made up of electrons. It is composed of electrons. So when I ask you what is the composition of beta radiation, it is composed of electrons which are negatively charged. Beta radiation, it is made up of electrons, it is negatively charged. Remember, electrons are almost massless. So we assume they also we just round off for their massless, and then we round off the speed also to speed of light, even though ordinarily a little bit of weight. Yeah, they're not entirely massless, but the mass is very minute to point where we consider them massless. Yeah, so the speed of electrons is not, remember what the speed is gamma 3 times 10 to the power 8 meters per second. So we just round off side electrons to 3 times 10 to the power 8 meters per second. But so this is a little bit slower. They are a bit slower because not massinya speed is only about 2.98 times 10 to the power 8 meters per second. The speed is a bit lower. But around the travel at the speed of light. Remember, they are negatively charged and they can ionize stuff. They can, if electrons go through, beta radiation goes through matter, it can ionize matter, it is negatively charged, and they will be, of course, deflected by the magnetic field. So sometimes what do you call alpha decay? Remember, extra neutrons. So we blame this topic of radioactivity on who? On neutrons. Har ka go botsa mo exam goreng which subatomic particle is responsible for radioactivity? Extra neutrons. Don't get that wrong in the exam. So you bring in these extra neutrons inside the nucleus. Le kgotlagano e ntse mo ga nucleus be go nna bothito be go nna le tsuka-tsukano go fetela go wankgata mo ga nucleus. So sometimes a proton can be like now I'm fed up anga di ka tlhola go nna le go ragaragana mo ga nucleus ke a sia. So proton e kgona go betsa ga ya ha e betsa ga gantsi ga ke tsamaya le one di tsamaya le two di patagane. It's like element e nang le di proton tse two ke mo periodic table ke helium. So it's like helium nucleus. It's like helium ion. So it's like helium ion. So the protons the two the bits from nucleus. How we alpha radiation. Alpha radiation. It is positively charged. These protons are positively charged. So you are going to understand that the composition of alpha radiation, they are protons. Protons, remember, they have mass, they have poor penetration because they are mass. And if they have poor penetration, what are the matter? So they are on that matter. And that matter is going to be heavily ionized with the positive charge or not positive charge. And they will also be, they are slow. Since they don't travel at the speed of light. They travel at a relatively slower speed. And then they are also deflected by a magnetic field. So these yellow, or there are three types of radiation produced by these radioactive isotopes: gamma radiation, beta radiation, alpha radiation. And why are we producing this? Because of extra neutrons. Because of these elements in the extra neutrons, they call them the isotopes. And an ordinary atom will not be radioactive. Only isotopes, only atoms with extra number of neutrons will be radioactive. Like for example, carbon-12 is not radioactive, but adding extra 2 neutrons to the regular carbon atom, you get carbon-14, and this carbon-14 is the one that is radioactive. Ko archaeology carbon dating carbon-14 because it can be detected because of its radioactivity. So, I will explain more uses of radioactivity. I'll mention carbon dating. There's a concept like a half-life. Discuss about lasting. I just wanted to give you guys this illustration because how they seeing is believing. Where do we get these three types of radiations? So I think this illustration will help most of you. And then, after that, they have this one is massless, this one is massless, this one is massy, this one is no charge, this one negatively charged, this one positively charged, this one poor penetration, most penetrative, moderate penetration, highly ionizing, moderately ionizing, no ionizing, highly deflected, less deflected by magnetic field. This one is not deflected. So we'll discuss the differences between all these and the whole topic. What is background radiation? What is an instrument called and the uses and dangers of radioactivity. So other than ka 7:30 so that I tell you guys more. I hope this illustration helps. Thank you so much for now.